now we put forth the question, how good is your estimate? Well, with nothing to compare it to, you're not really sure. I mean, we had a couple examples where we found the exact answer from the calculator. I mean, by using fundamental theorem. But without that, how do we know how close we are? Well, that answer is given in this theorem. It gives us a bound for the error for each of the techniques that we have, trapezoidal and Simpson's rule. So we're going to go through how you use that for each case. So we're going to do number 3 here. We'll do it in 2 parts. Here's our integral, and we're going to use the error estimate formula to get a handle on the size of this error. So let's start it off. We'll have that the error less than or equal to b minus a, so 4 minus 2 to the 3rd power over 12 times 4 squared times the maximum of the absolute value of f double prime of x, where the x is between a and b. Okay, so this is the unknown in our formula here. We have to get a handle on this size here. So let's look at the derivative. F equals 1. Well, let's just write it. X minus 1 to the negative 2. So f prime is a negative 2 times x minus 1 to negative 3. F double prime, 6 times x minus 1 to negative 4. Okay, now let's look at that function here without having to go through too much effort here. This is a 6 over x minus 1 to the 4th. So we know graphically what does that look like. Well, at 1 here, there is this asymptote, and the curve comes through like so, heading down. And over here, on this side, it's doing something like this. So the point is, between 2 and 4, which is 2 and 4 is over here, it's pretty clear that your maximum for this portion of the curve occurs right here at x equals 2. So we would say that this thing can be no bigger than 6 over 2 minus 1 to the 4th, which is basically a 6. So we have a handle on this thing here. That means that this error will be less than or equal to, that's a 1 over 12 times 16, and then times a 6. So we can reduce that. We'll have 1 over, looks like 32. Okay, so that's going to be our error. The bound on the error. So since it's in this form, remember, it's somewhere in here. Like that, 1 over 32. So we can be sure, using n equals 4, that the error is no larger than 1/32 for this formula using the trapezoid rule.